Hey there, everybody. So in just a few minutes, I'm going to hop into this, and we're going to be talking a little bit about variable choice in regression analysis. Now, a couple things about this that need to be said before we get into it. There is no objective answer as to what are the correct variables to include and what are incorrect variables to include in any given estimated regression equation. I am going to walk you through a few of the signals that suggest sound variable choice and also suggest unsound variable choice. But again, these are not definitive. And so, the first thing I'm going to do is I'm just going to run a regression using this housing data that we've used before. So here we see the corrected price. It's corrected for inflation. I'm going to introduce a constant term, and then I'm just going to throw in some variables, and we get this regression output. So I've only included one variable here, the living area of the house. We can see that it has a positive coefficient. Just going to pause this here for a second. We can see that it has a positive coefficient. It looks like living area now. This is a linear model again, linear functional form, and so we can say that. It looks like that coefficient is telling us that every additional square foot of housing space gives us another $70 on home sale price, or something along that lines. Now the R squared and adjusted R squared are very poor on this. We'll come back to that. The T statistic here is telling us, this 18.14 is telling us that this is a significant relationship. In other words, there's living area has a statistically significant impact on home prices, according to our model, right? Okay, so let's keep going. All right, now I've hit freeze there, and what freeze does is essentially takes a snapshot of this, right? And so I'm going to put that snapshot down over there so I can kind of remember this. And then I'm going to run another regression. Now, while I'm running this, and I have this moment to sort of talk with you, it should be said that what we're doing here, sort of, kind of plowing through a very roughshod by running additional regressions to try to get some kind of results, that's really not good econometrics. Sort of continually running and rerunning just without any thought in mind, really. It's not a good way to do things. It's not likely to yield good results. Okay, so I've just moved stuff around here a little bit. We see in the second regression equation, I've included a second variable. Now I'm including also the lot size. And again, I've grabbed a snapshot of that and put it next to my other one. And again, before we go any further, I just want to pause here for a second. Now you'll notice that the R squared has gone up a little bit from the previous one, meaning that we're explaining a little bit more of our variation in our dependent variable, or the home price. You'll notice that our coefficient associated with our living area has gone down, right? So it was 70 before. I can see it, down over there, 70.16, and now it's 58.35. Okay. Does that mean that suddenly, living space got less valuable? No, of course not. What it means is that we had an omitted variable bias in that first estimator. In other words, some of the other things that, see the theoretical video on this for more on that. Suffice it to say that this is what we observe when we have a variable that's important and is missing. Now, when we included that second variable, in this case lot size, we can see we get a positive coefficient on there, and we also get a significant t-stat associated with it. Okay, meaning that our second equation is telling us that both of these variables have a statistically significant impact upon home prices. Okay, right. Our R squared is still three just under 3.9. So not too great. Let's keep going. Okay, so you see I've got the snapshots, the freeze, right? Hit the freeze thing there, and you can sort of take a snapshot of each one of these. I'm going to run another regression now. I'm going to add some more variables in and kind of see what's going to happen. And again, the second note on this, sort of shopping regression stuff here, not really good practice. We're doing this, or I'm doing this for pedagogical reasons, just to show you what's happening to these as we sort of add stuff. So I'm going to add whether the house has a deck on it or not, right? The deck out back. Could be out front too. It doesn't really matter one way or the other. Oh no, hang on, sorry. I threw myself for a loop. Whether the house has heat or not. Anything of this is crazy. Like, well, a lot of these are vacation homes, right? So some of them don't have heat. All right, so now we have these two, right? And we have this third variable, heat. And we notice that T statistic, 0.58, is quite low. And indeed, what our model now is telling us is that, I'm going to pause this again. So what our model is telling us there is that our added variable of heat really isn't telling us anything meaningful about these home prices. And I suspect that it's been 4 years since I really was playing around with this data set, but as I recall, it's a pretty small number of observations in this data set that doesn't have heat, like less than a dozen out of 612 or whatever. And so it probably shouldn't be surprising that this isn't significant. And so in this case, what we're seeing is that we've added a variable that really isn't helping us at all. Now, the other thing to note about this is the coefficients on those other two variables. You notice that they haven't moved around much this time. Okay, so it was 5835 on living area before, now it's 5837. Okay, the standard error very close to the same as before. The t-stat nearly exactly the same. Same for the other variable, lot size. Okay, that's sort of stability as we're sort of adding, subtracting things here, right? That sort of stability is a good sign, right? If it isn't stable, right, then we have some, it's almost certain that we have some very important omitted variable. Again, see the video on the theoretical reasons or theoretical explanations of omitted variable about why that is. But suffice to say, if those variables, those coefficients are moving around, what's happening is that a lot of the variation is from something else, right? That we're not seeing is getting captured in that estimated coefficient. Okay. So again, here I'm kind of pointing out this relative stability, and so what we have here examples sort of both ways, right? What it sort of looks like when we're adding variables that really don't tell us anything, like in this case heat, or when we're missing variables that are obviously really important, like the size of the lot. All right, thanks everybody. That's going to be it for this time. We'll see you again next time. Take care.